Firstly, I would like to acknowledge my co-authors, Sabita Jha from Agriculture and Forestry University, Dr. Madhav Kumar Shrestha from Agriculture and Forestry University, and Jim Diana from the University of Michigan, Ram Bhajan Mandal from Lamjung campus, and lastly, Hilary Igna from the Oregon State University. Agriculture and Forestry University has been promoting the carp seeds polyculture since 2008 because this technology is sustainable and it supports both the family nutrition and the income generation. The technology, although is sustainable, but the feed cost is still high. So we felt that we should do something to reduce the feed cost in the technology. Therefore, our attempt is to do the research on reducing the feed costs. The investigation actually had the objective of developing the low-cost sustainable technology through the on-station trial and then the transfer of the technology to the farmers through the on-farm training. The investigation has two parts. The first part was the on-station trial and the second part was the on-farm trial. The on-station trial was actually the master thesis of the Sabita Jha. She did her thesis in Agriculture and Forestry University in the earthen ponds. The average size of the pond was 151 square meter, and she completed her thesis in 7 months. The objective of the on-station trial was to compare the water quality among the different polyculture systems, then to compare the income or the profit among the different polyculture systems, and also to compare the net yield of the carp and small indigenous species among the different polyculture systems. The experiment was carried out in completely randomized design. The experiment had 4 treatments. The treatment 1 included only the carp polyculture, and the feeding was 100%. Substrate was not provided to the pond. And in treatment 2, the carp and seeds were stocked together, and feeding was provided 100%. No substrate was provided to the pond. And in treatment 3, carp and seeds were stocked together. The feeding was reduced to half, and then bamboo mat was added to the pond. Actually, the idea of adding the bamboo mat to the pond was to increase the surface area for the algal growth, that is the natural food of the fish. And treatment 4, carp and seeds were stocked together. However, no feed was provided to the fish. There was the bamboo mat. The stocking combination included the 6 carp species, and the stocking density was 15,000 fish per hectare. And in addition to the carp, in the treatment 2, 3, and 4, 2 small indigenous species were also stocked. Those were pothi and dedua. The stocking density of each fish was 25,000 each. So altogether, 50,000 fish per hectare was added for the small indigenous species. The pond preparation included the application of the fertilizer, urea, and DAP. The application rate was 470 gram per 100 square meter and the 350 gram per 100 square meter. After that, substrate was installed to the pond. The substrate was prepared by the split bamboo in the form of the mat. Altogether, 20 to 35 bamboo splits were used to form the mat, and the size of each split was 4 centimeter wide and 75 centimeter long. And in order to keep the substrate to the pond suspended in the water column, styrofoam was tied to the top edges, which served as the float, and the brick or the stone was tied at the bottom of the mat so that the mat was suspended freely in the water column. In each pond, 2 mats were suspended and the position was vertical. These were the pictures of the Sabita Jha preparing the substrate, and she is being helped by her colleagues, stocking and conditioning of the fingerlings. After the stocking, fish were fed by the dough of the rice bran and mustard oil cake. They were mixed in 1:1 ratio, and the fish were fed once daily in the morning. The feeding rate was initially 5% for 2 months, and the remaining months 3% was kept. And in case of the grass carp, only the grass was fed, and the feeding rate was 50% of the biomass. The partial harvesting of the small indigenous species that was done monthly during the sampling of the fish, and final harvesting during that was done in the March by complete draining of the pond. Analytical methods included the growth check, which was done monthly, and sampling at least 20% of each carp species, and also included the water quality analysis, periphyton analysis, gross margin analysis, and statistical analysis was done by the one-way ANOVA and the student's t-test. Coming to the result, the net fish yield of the carp and the combined, that means the total yield of the carp and cease, was found higher in the treatment tree. That was the carp and cease polyculture, where the feeding was reduced by 50% and substrate was added. The gross margin was also higher in the treatment tree. So based on the income and the gross margin and the production, the treatment tree with carp cease polyculture, bamboo substrate, and the 50% supplemental feeding was found to be the best. Now the second part, that is the farm trial. 2 best treatments from the on-stand trials obtained were tested in the farm in the Tharu community, and the trial period was the 8 months beginning in the April 2015 and ended in the December 2016. The trial sites were the 2 districts. One is the Chitwan and another is the Nolparasi. In the Chitwan, Sundardeep women cooperative women farmers participated, whereas in the Nolparasi, Misrit cooperative farmers participated. So altogether, 37 women farmers participated in the farm trial. So 19 farmers were included in the carp and plus 100% feeding treatment, and 18 farmers in the carp cease polyculture with 50% feeding and the substrate treatment. Coming to the methodology, all the steps such as the pond preparation, stocking combination, density, and the food and feeding of the fish were almost same as in the on-station trial. Only the difference in the replacement of the styrofoam by the plastic bottles by farmers in the substrate was done. Rest are same. Farmers kept the record of their amount of the fish consumed, then how much amount of the fish sold and died in their book. Then farmers started eating the fish, small indigenous fish, from the July, because from the rainy season, small indigenous fish starts breeding. These are the self-recruiting fish. Final harvesting took place in the December 2016, and we could not do the complete harvesting because that time the oil crisis was there, fuel crisis. So the complete draining of the pond was not done. Now, fish production, consumption, and the profit earned by farmers in 2 systems in 8 months. Then when we analyzed the data by the t-test, we found that the carp cease polyculture with 50% feeding with substrate had the highest production and the profit compared to the carp polyculture. And coming to the consumption, this data did not differ between the 2 treatments. The district-wise fish production and consumption and the income showed that in Nolparasi, the gross income and total production was higher, whereas the consumption of the fish was higher in the Chitwan district. At the end of the farm trial, we also conducted a workshop to transfer the technology, that is the carp cease polyculture with reduced feeding system and with the substrate. So the participants were the 37, among them 7 were the men and 28 were the men, and these participants were completely non-adopters. To conclude, the technology is viable because it utilizes the locally available bamboo and which can be reused for 3 to 5 years. The technology is suitable to the rural small-scale farmers because it is cost-effective and also supports the family nutrition and income. And technology needs the upscaling. Lastly, we would like to thank Aquafish Innovation Lab for providing the research grant. And we would also like to thank all the farmer participants, the women farmers of this project. Thank you very much.